Recording in progress.
Hello students, myself Dr. DheerajTandoon. I am the Associate Professor in School of Engineering of BBD University, Lucknow. Today I will cover the topic of the theory of automata, that is the push-down automata, or we can say the PDA. So first of all, I will explain what is the PDA, and after that I will explain how it will work. What is the push down automata? Push down automata is more powerful in comparison to the DFA or NFA, that is a deterministic finite automata or non-deterministic finite automata. Which feature make it more powerful? Because it is using the memory element with the help of the stack, so it becomes the more powerful in comparison to the DFA and NFA. We can define PDA with the help of the 7 tuples. What they are, these tuples, I will explain later. But you should know that the PDA will accept the CFL, context free language, that will created with the help of the context free grammar. The abbreviation of the context free grammar is CFG. We can push the element in memory element, that is created with by using the stack, and we can delete or pop the element from the memory unit, that will created with the help of the stack. So these are the 7 tuples that will create the PDA. What are these 7 tuples? First tuple is state, that is defined with the help of the capital Q. Second tuple is input alphabet, that is defined with the help of the symbol sigma. Third tuple is stack alphabet, that will be abbreviated with the help of the tau. Fourth tuple is transaction function, that is defined with the help of the delta. Fifth tuple is start state, that is indicated with the help of the Q naught. Sixth tuple is the start symbol, and this will indicated with the help of the Z naught. And the last tuple is the final state, that will indicated with the help of the capital F in PDA. What is the transition function in PDA? As you know, in the CFG, what is the transition function? In DFA, NFA, how it will work. But in the case of the PDA, it is totally different. We can define the transition function with the help of the 3 arguments in left side and 2 arguments in the right side. So what are these arguments? First of all, in state Q, we are giving the input symbol A, but at that time the top of the stack is indicated with the help of the Z. After transition from the state Q, it will go in the state P, and the top of the stack is defined with the help of the alpha. So right side will show the transition of the PDA. So this is the action of the PDA. We can push and pop the element from the stack. Here I am taking an example that will explain you the PDA. What is the PDA? I am taking a language 0 to the power n and 1 to the power n, where n is greater than or equal to 1, and it will accepted by the PDA. The PDA, how I can say that the PDA will accept this language or any language? There are two methods by which we can say it will accept the language or not. The first method is with the help of the final state, and the second method is with the help of the empty stack. If at last stack will be empty, then it means it will PDA will accept the language. So here in this example I am taking the three states that are the P, Q and F, where F is the final state. So if I am reading, if PDA is reading 0, then it will insert the capital X in the stack. So how we can write the transition function in the PDA? Suppose in the state Q, if I am giving the input 0, at that time in stack there is at the top Z0 symbol is inserted. Then after transition the state will be Q, and the top of the stack will be X Z0. This is the first transition function. In the second transition function, if I am inserting 0 and at the top of the stack is X, then after the transition the state will be Q and the top of the stack will be XX. Similarly, if because we are working on the language 0 to the power n and 1 to the power n. When 0 occurs, it will insert the X. But if 1 occurs at the time of the reading, then it will pop the 1X from the stack. So the next transition function, if there will be 1 occur and the top of stack will be X, then it will transition from state Q to P and there will be the epsilon. Similarly, if the state is P and we are inserting 1, but at that time at the top of the stack is X, then again it will pop 1 X from the stack. But at last transition function, if there is a epsilon at the inserting time, but the top of the stack element is Z0, then it will accept and it will reach on the final state that will be indicated with the help of the F and at Z0 at the top of the stack. So these are the transition function that will accept the language 0 to the power n and 1 to the power n. I will explain this creation of the PDA with the help of an example. I am going to use the PDA to accept 0 to the power 3 and 1 to the power 3. It means 0, 0, 0 and 1, 1, 1. How it will accept? So this is the initial state where the state is Q and I am inputting 0, 0, 0, 1, 1, 1 in the PDA, and at the top of stack is Z0. So when 0 read by the PDA, then X will be inserted in the stack. Similarly, in the second state, if the second 0 will be read by the PDA, again it will push X in the stack. Again, when third 0 will be occur, it will push third X in the stack. But this is the turning point in this language. If there will be 1 occur, then it will pop 1 X from the stack. If second X will be occur, then it will again pop 1 X from the stack. If the last one will be occur, it will pop all the X's from the stack, and at last only Z0 element symbol will be exist in the stack. At last, if it will read the nothing, no string, then it will reach at the final state, and at the top of the stack will be Z naught. Uh, we can explain these moves with the help of the instantaneous description of the PDA. What is the instantaneous description, or we can say the ID? It will show the all moves of the PDA. So you can see at the state queue, I am giving the string 0001111. At that time, at top of the stack is Z0. This is the turnstile symbol, or we can say move to state queue, and 0 will be removed from the input string, and instead of 0, I will push the X in the stack at the third argument. Again, when second 0 will be read by the PDA, it will push the second X in the stack. Similarly, third 0 will be read by the PDA, and third X will be inserted, or we can say push in the stack. When 1 will be occur in the PDA, it will pop 1X from the stack. Similar process is repeated again and again, but at last it will at last in the stack there will be only Z0 element will be remaining. So I can say that this language 000 and 111 will be accepted by the PDA. We can again check the next language. In this language there are 3 zeros and 4 ones. This will be accepted or not? You can check very easily. At last there will be more than one symbol Z0, and one X will be remaining in the stack. So we can say it will not accepted by this PDA. So this is all about the PDA. Deterministic PDA. DPDA will accept all the CFA. In the case of the second method, we can say if there will be no element remaining in the stack, it will accept the language. So there are two methods by which you can represent the given language is accepted by the PDA or not. Okay, students. Thank you very much.